Okay guys, we are starting our new lesson today. We're doing piecewise functions. Everybody in this class knows how to graph a line, correct? We've done that in the past. Everybody can start with your y-intercept or make a table and graph your lines. So the piecewise function is where you take pieces of graphs between different intervals and you graph them on a plane. Okay? On the same plane, that way you see the different parts of them. So what I'm going to do is I'm passing around. Everybody needs a pencil and a pair of scissors, either glue or tape. You guys can pass your glue or tape around if you'd like to share. So clear off your desk except for that stuff. That way it's not like a mess and we're trying to get this stuff done. So just your packet, your glue, your tape, and a pencil.
Your catch.
Either glue or tape, one or the other. And don't cut anything, we'll cut everything together as needed. Who took my scissors off my desk? No, get your own, please. Thank you.
Natasha
Okay. Is there not more tape in there? You guys can pass glue and tape around. Who has tape?
I have tape.
Yeah, definitely. Alright, there should be enough scissors to go around. You check the basket back here, Mackenzie?
No, I got one.
Here, I'm good. You're good? Everybody has scissors? Yeah. Okay. Jacob. You don't have to.
Dang it!
Okay. Will you turn the lights off, Jacob, please? Are you guys good with seeing wise, or do you need one light back on?
I'm good. This is Natasha.
Yes. Do what?
Let's go to the bathroom.
Yeah, go ahead.
Part of the camera. Climb up the table. Wait, we're going to the bathroom before this starts. Can I go?
No, we're not going to the bathroom.
Can we
Can I
keep
go to the
calling
bathroom?
us?
Don't knock it over.
No, once Lauren comes back, you can go to the bathroom. Only one at a time. Okay, guys, listen. But remember, if you go out of the classroom, you're probably going to get a little behind because we're
I'll get it.
doing this as a group.
before you.
Okay, listen. So the first thing says, it's on your paper, the same words. So just follow along on there if you can't see very well. All right, here's a little better. All right, so the first thing says, make a table of values for the function y equals 2x minus 1, including the points x equals -3. This is in our table over here. X equals -3, -2, -1, 0, 1, and 2. Graph the function y equals 2x on the first graph. Your graphs are on...
May I get a calculator?
We don't need calculators. Your graphs are on the back of your sheet, so you can tear this off and use it as your graphs. So here's my question. If I plug in the number -3 into my first equation, what comes out of that? So my input is -3, right? What's my output going to be? So we have y equals 2x minus 1. When I put -3 into that function, what do I get out? 2 times -3 is -6 minus 1. -7. Good job, Jasmine. Okay.
Oh, is it? Sorry.
Okay. Next, if you plug -2 in, what do we get out?
-5.
-5. If we plug -1 in, what do we get out?
3.
What's happening each time?
Minus.
As our graph goes up by 1, as our x values go up by 1, our y values are also going up by what? 2. So what's this number here going to be? And then from -1 up 2 gives you, and then from 2, there you go. Everybody see that, right? So take those points and put them on one of your graphs. So take your graph paper and plot those points I have on the board. You can write them in your own table too, on your paper. And tell me what they look like, or show me what they look like by your own graph.
How come you have? Oh,
Wait, did you just say to do the right hand?
No, just do those 3, or that one graph. We're going to do this all together. So everybody's on the same page. So if you have questions, you can ask as we go through. So at -3, where's my y value?
-7.
Okay, so -2 is at
-5.
-1 is at -3. And continue on. So your graph should start to look like this, correct?
Yes.
Everybody see it? And how else could we have graphed this line without using a table? Anybody know?
Over 1 up to no.
Okay, so we start from where?
-1.
-1, and then we go, Hayden says, not over 1 up to, what's our slope?
Up to.
What's our slope? 2, so how many do we rise?
2.
And over 1, right? Okay,
Wait.
so we could have done it either way.
It's the same.
No. Everybody good so far? Okay, so it says, we graph the function, making sure the points on the table are exact on your graphs. Next says, make a table of values for, okay, so next table of values for number 2, for the function y equals -x plus 3, including the points x equals 0 through 6. That's this next table down here. And we're doing that with the equation y equals -x plus 3. Okay? So go ahead and start filling in your table. With the function y equals -x plus 3, you're going to fill in the table with the values of 0 through 6. You guys getting that okay?
It's crazy, we got the same answer.
It's crazy, right? Good. What's happening to my graph as my y values or my x values go up? What's happening to my y values? Good job. They're going down, right? Okay, so as Maya just said, they're going down. So we went 3, 2, 1, 0, 1, 2, 3, right? So now that we have both of our tables filled out, or go ahead and graph your second one on another piece of this here. So you have your first graph, and then go ahead and graph your second. It doesn't matter which graph you do it on, because they're all the same. Just go ahead and graph your points. And other than the table, how could we have graphed this one? Anybody have an idea? Where could we have started with our graph? +3 on the y-axis, and then where would we go from there?
-1.
So, negative one slope.
-1, 5, -2, 6, -3.
Yeah.
Yes, thank you. Perfect. All right, so you have your 2 sets of graphs, or your 2 graphs on the paper, correct? Everybody good? Good, Alan? Okay. So now it says, step 3, on the first graph, draw 2 vertical lines at x equals -2 and x equals 1. So x equals -2, and draw a vertical line. Which way is vertical? Up and down. Okay, and then at x equals 1, we're also going to draw that same vertical line.
Wait, why are we doing this?
Do what?
Why are we doing this?
We'll see in just a minute. It's going to come out to be an amazing thing.
Wait, where did it tell us to do that?
And number 3. Number 3 is on the graph. Draw 2 vertical lines at x equals -2 and x equals 1.
Oh, I got
Just
it.
on the first graph. Okay? Now go ahead, it says, cut your graph out. So cut this graph in 3 pieces, right?
Yeah.
3 pieces, just like on the board. Make sure it's right side up. Make sure your graph's not upside down, or when you graph it, it's not going to work out right. Okay, so our next step says to take the middle piece. It says in the middle of step 3, take the middle piece of your graph, right, and place it on, this is your top page, the graph down at the bottom of your top page, line it up with your axes. So it should look something like this. See how mine is? Line it up correctly and glue it or tape it, whatever your medium you are using.
Wait, did the middle?
Do what? The middle piece, yes.
I need this. Somebody.
I have, there's tape in the room. You guys might have to pass them around. I'm I'm running a little short. And match it up the best you can. So here is my little graph. Does everybody see it?
We're still doing it on the one maybe
Do you have tape?
Yes.
two, right?
No, I don't have tape. Here's a glue stick though.
Okay. I don't have it.
Well, no, I'll come get it when I need it.
I'll just take it out.
Okay, that's fine. Yeah, there's glue stick, but there has to be, I didn't know there has to be one
Who
around.
needs one?
Alright, so everybody's graph is looking like this.
We do it on -2, 1, right?
We'll share.
Yeah, do it the same way, so it should look like this.
Oh, wait. Too bad. Get over it.
Well, this is, I mean, eventually you will draw. This is an activity to show you where it comes from.
Mine doesn't go all the way to -2.
There's gonna be.
It doesn't like completely match up.
Cut a piece off.
What?
What do you mean?
It doesn't like fit to -2.
Let me see.
See, there's like still a little bit of a line right there.
I mean, that's fine. Yeah, as long as it's on the right, like, axis part and stuff.
So
Like,
this is right?
yes.
Okay.
No, you know why it doesn't match?
Yeah.
Or yeah, I'm upside down. Okay, you're good. First I was like, did you do it right? But I'm upside down from it, so you're good. Yep, that's right. Okay, everybody good with this part? So now it says on your second graph, guys pay attention, on your second graph here, the one we drew from our second equation, it says to draw vertical lines, row number 4, at x equals 1, x equals 5. So
cut it out?
you can just cut it out if you like. But x equals 1 is here, and x equals 5 is here. And again, cut it out just like you cut out your previous one.
Wait. I can't hold something. Where's mine?
It's that x equals 1, x equals 5.
Let's get
Okay.
glasses. Okay.
There you go. Get those glasses out.
Oh, wait, I don't have it.
I almost left my house without my glasses this morning.
Smart.
No, not for them. All right, so everybody is cutting, right?
Possibly.
I got to like the end of
So
my
remember,
work.
cut your graph out first and then cut along your vertical lines. If you didn't draw your lines, but you know where they are, that's fine. Just make sure you cut the correct place.
I don't know where.
We're getting ready to find out where we're going.
There.
All right, everybody good?
Do we cut the entire graph out?
Yes, and you're gonna save your middle piece again. So save the middle piece of this graph. It should look like this.
outsides at all?
No. The outside you can throw away. We're not gonna use this.
Oh, never mind.
So you need this middle piece right here from your graph.
Can I put it right beside it?
So you're gonna put it on your bottom graph, as Allie just said, right next to the other one, between 1 and 5, and line it up.
Whoa.
Does it fit?
No.
What?
What? So go ahead and glue tape, whatever you're using, it down there.
Why is it like uneven?
Well, I will explain that in just a second.
Natasha,
Yes.
Natasha,
Miss Natasha, I will.
You said between 1 and 5?
Yes, because that's what we cut out, between 1 and 5, right? Yes. Where's your second graph?
That's what it looks like. Let's do that.
Okay,
I
so
did
we
it
start
upside
at,
down first.
second graph is here, right? Where am I starting when I graph this? Okay, so you go up 3, put your dot, right? And then where am I going from there? That's my second. We're down 1 over 1, right? What do you need to do? And then draw your graph. And then your line is going to be at x equals 1, right? Yeah. 2, 3, 4, 5, x equals 5.
I'm
Just
struggling.
cutting along the line, the vertical line.
Very mature.
Does everybody have their, you're getting it though? Okay, you got it?
Can't believe you made me turn it the wrong way.
Did I make you turn it the wrong way? I'm sorry. It's okay, Jasmine's here to keep you straight, keep you straight.
No, I.
Yes.
Sound good?
Okay, guys, so let's see what we just did here, right? Let's see what we can discover from this activity. If you look beside your graph, right, these are called restrictions over here, right? These are your equations. F of x equals these two equations, and these are the restrictions to where they equal that equation, okay? So, for example, right here, we have when negative 2 is less than or equal to x, that's less than or equal to 1. That means between negative 2 and 1, right? We should have 2x minus 1 graph. So go look at your between negative 2 and 1, and that's what you have graphed, correct?
Yeah.
Does that make sense? So then also between 1 and 5, you should have negative x minus 3 graphed. So between 1 and 5, that's what you have graphed, correct?
Yeah.
And we did that by making a table of those values. So if I asked you for this set right here, this whole entire set, what is the value when x is 2? What are you going to tell me? Where is x2 on your graph?
It's 1.
X is 2 right here, right?
Yeah.
And from there, our y value is 1. So when x is 2, y is 1. So if I say, what is f at negative 2, right? What are you going to tell me?
It's 1.
Well, where's
Negative
negative 2? 1, 2, right?
Oh, wait.
And we go down 1, 2,
It's 5.
3, 4. You say 5?
Negative 5.
Negative 5, okay. Does that make sense? So we're going to go over, this was just kind of to show you guys the pieces of the graph. We're going to go over one more example together, which is the next problem on your packet. It's on page 2. But we're not going to cut this time, we're just going to draw it. And then I'll have you guys do the last problem on your own, just to make sure that you're good to go with it before I give you your assignment. We're not going to cut on this, and we're just going to draw, because I want you guys to, on the assignment, I mean, you can if you want, but to me, once you see it drawn, it's easier to draw them and less complicated. Okay, so flip your page over to number 5 is where you should be.
6.
6, my bad. There you go. Told you, Cody, you gotta keep it straight. Yeah. All right, number 6. In this case, how many equations do we have?
5.
3, right? We have
Wait, never mind.
f of x equals 3x, f of x equals 6, and f of x equals negative x plus 10. Okay? So, and here's our stipulations. So for our first one, what are our x values between?
0 and 2.
0 and 2. Does it include 0?
Yeah, like this.
Yes.
Why does it include 0? Because it has the equal sign. Does it include 2?
No.
No, because the sign's not there. However, it does include every single thing up to 2. Does that make sense? So it includes 2.8 or 2.9. I mean 1.8, 1.9. Okay? So, let's go ahead and start. So we're saying between 0 and 2. So let's plug in 0, 1, and 2 into our table, right? And see what we get out. So if we plug 0 into this function, what do we get now?
0.
0. If we plug 1 in, what do we get, Cody?
3.
3. There you go. If we plug 2 in, 6. So let's graph these. So at 0, 0, and then at 1, 3, and then at 2, 6, are we including 2, 6?
No.
No, so instead of a closed dot, what should we have?
Open.
Open dot. So see how I did my dots? So now let's draw that segment. It's just going to be including in this little area, right? Nothing else around it because it's just between when x is 0 and x is 2. Does that make sense? Everybody with me? Yes. Okay. Next equation is between 2 and 4. Is it including either of those?
2.
No.
No. So we're going to say 2, 3, and 4 are going to be our x values, but we're not going to include the 2 and the 4, just everything in between. We plug 2 into this value, what do we get? We're doing the second function now, right? Is there an x value there? So it's, there you go, good job, it's 6. If we plug 3 in there, what's it going good job. 4 is also 6.
Six.
My last class, so we better add another number there. Alright, everybody good on that? So, at 2, 6, we already have that, right? And it's open, that's how it's going to stay. At 3, 6, we need to put a dot, and it's included, right?
So it's close.
And at 4, yes, good job. At 4, 6, is that included? No, so that's going to be an open dot also, right? But our line is going to fill in everything in between. Does that make sense? You guys with me so far?
This is a weird line.
This is called, what are we taking of each graph? We're taking a what? From each, like we cut our graph into 3 parts.
The middle.
A piece of each graph, right? So it's called piecewise functions. Alright, so our last equation is negative x plus 10, right? So what numbers are we going from? 4 to 6, so let's put them in there. 4, 5, and 6. Are we including 4? Are we including 6?
Yes.
Yes. So when we plug 4 in, what do we get? 6. Good job. If we plug 5 in, what do we get? What do we get? 5. We plug 6 in, good job, we get 4. So we said our 4, 6 is not included, that's already listed there for us, is not included from our previous one, right? But 5, 5 is included, right? And 6, 4 we said was included. So this is what your final graph looks like.
What?
Kind of neat though, right?
Yeah.
I mean, it's not the normal,
It looks like a thing.
yeah.
Yeah.
It looks
Looks
like,
like a fishing
almost like a
rod.
little, yeah, or like a little
Or it's
pirate.
like the stars, like when you
Like a
do.
little dipper type,
Yeah.
yeah,
Constellation.
constellation, constellation.
Testally.
What's a testellation?
I don't think it's
It's
worth
not a word, sorry, I knew that I not. Okay, so listen, this is the way you're gonna graph these, okay? Now some students, and it's okay, whichever works for you, will take a pencil, right? And graph the function, like you guys can graph 3x by starting at 0, 0, right? There's no y-intercept. Going up 3 over 1, and continue with your slope, and then erase it to get its boundaries. Does that make sense? You guys understand what I'm saying? Like graph the function, like for example, at 3x, if we start at 0, 0, right? Where my pen is. Our slope is 3 over 1. Go up 3 over 1, up 3 over 1, right? And keep going to make your line, and then you erase everything except between 0 and 2 on the x-axis. Does that make sense?
Yeah.
To bring it back to those boundaries. Some students do it that way. I think the chart is probably the easiest way.
I like whatever this is.
Try number 7. Number 7 is a little bit different because it doesn't, the first part doesn't have a, a closing point. It just says from x is greater than 0. But go ahead and try it out.
You had to give us the fact.
It's a half. A half of something is easy to take. That's okay.
I'm doing the second one first.
Okay, grab it. I mean, you can do either one in first, second, however you want to do it, it's fine. Just make sure you're, I'm going to turn one light on because
Can I use a calculator?
you don't need a calculator.
Why?
Do what? Well, what are you trying to do? If you plug 0 in, 0 times a half is
It's art.
plus
Okay.
4. There you go.
That's it.
And your slope's telling you you're going up how much each time?
Oh, wait. What?
What is your slope telling you you're going up by each time?
Maybe later.
What is your slope?
This is saying
Are you doing the first one, second one? Okay, what's your slope? So are you going up half every time?
But what if we like couldn't get it off? We
Yeah. So what's your next number going to be?
glue
So it's going to be 4 point.
stuff.
There you go.
Why would you wait till
And then,
Yeah.
there you go, see?
Let's do it.
Are you good? Do you understand it? Are you doing this one first?
Yeah.
Okay, so what's happening every time? Yeah, we'll just need 5, yep. Right. And then what's
Right
next?
there it says if, wait, no, that would, I don't know what that means.
Are they all open?
That would
make
five. Yeah, good job, Mackenzie. It's going up by
Are these
half
all
every time.
closed?
Well, I know how to do
Did
that.
you what?
Yeah,
Are these
you have
all
0.
closed?
No, they're the opposite, right? What determines whether your circle is open or closed?
If there's a long
Less,
or.
If there's the equal to line with it, good job, Allie, she's on top of that one.
Wait, I'm on top of it.
0, and it says x is less than 0. So if you start with 0, what numbers are less than 0? There you go. Are you good?
Really?
Okay, what's not? What's up?
I don't know how to.
Okay, because they're both open, right?
Yeah.
Because there's no equal to it.
Oh, so there.
Yeah. Not all the dots, just the ending dots. Does that make sense?
Just the ending one?
Yeah. Just try your best and do what you can. We're going to go over it together in just a minute. I just want to see how well you guys can do as far as starting it. All right, so here's your first one, right? And it says when x is less than 0. So starting with 0, what's the numbers less than 0?
So they're right there.
Yes.
Cody, what'd you do right?
Hey, we're recording. It's okay. What's next? Yes, what's next?
Try to roll them?
Yes. Or, I mean, you can stop whenever you feel comfortable, like you can get it a good line. Does that make sense? Okay. Okay, keep going. I think he's saying because you're in a class full of girls. All right. I probably moved it past it. All right, so when you plug 0 in for x, what do you get out for y? 0 times -2 is
It's like, Cody, what'd you do right?
plus 4. There you go. Does that make sense? And your slope is -2, right? So what does that mean is going to happen each time you're going to what?
We did the same.
Go up.
Well, it's negative, down by 2 every time. So from 4, if you go down by 2, what are you going to
Lauren, what do you think the
Wait,
first graph is like?
Natasha.
The first graph? Yeah, that one.
That's
be?
what.
Well, it's, if you can't do that, plug
Yeah.
1. So -1 times -2 is plus 4 is
What's
-2 times -1 was
Are so
+2.
creative.
Plus 4 is
It's like a.
6.
So it's 8.
There you go. Yep.
That's what I was saying.
Why was it named? Because you're going down there instead of up.
It
You're
could
going
be a
up,
worm.
down by 2 slots. Does that make sense? Because your slope's negative.
You guys are creative too. Sorry.
Do what?
I
Yeah.
made a worm.
Yes. And so it's saying from 0 less than. So when you draw your line, right? And then you keep it going. Because the less than doesn't stop it.
Okay.
It doesn't have anything here to stop it. Does that make sense? So now go ahead and do your next line. All right, everybody doing okay?
No, I need help. We need help.
You need help?
I'm not very good at this.
Okay, so put in, it's saying x is less than 0, right? So from 0, what's the number less? And you probably want to include 0 too, like 0 what number leading up to, does that make sense?
What numbers are you using? Don't forget.
It says x is less than 0, so starting at 0, and then put some numbers less than 0. Yeah. Are you good?
So for the first thing, we put 0 and then numbers less, like
It says x is less than or equal to 0, yes.
Never mind.
So if you put -1, no.
So,
-1 times -2 is plus 4. Yes. All right, you guys good over here?
Yeah.
All right. So are we ready to go over it?
Does it go by 2? You check
Yeah.
Look.
I can't tell if they're closed or open.
All right, your numbers look correct. So 0, 4, and then as we went down, we went up. So if this is 4, right? Where's 4.5? And then 5.
What did I do?
I don't know. I think you skipped up a couple. I mean, you did the right like line. Does that make sense? You did it the wrong place. So you're good.
Mine's correct.
Yeah.
Yes. Are you good, Lauren?
Do we need any more Natasha?
I think.
Okay. Let's go over. No, you don't need any more of your
I
draft.
don't know which ones are closed and open.
Okay. Well, let's discuss that real quick. Okay, guys. So help me out here. What are my points for the first graph? It says if x is less than 0. So where do I start?
0.
And then I go less than that. So what numbers do we use?
-1, -2.
Okay. And then when I plug these numbers in, when I plug 0 in, what do I get out?
4, 6.
Okay. When my second equation, what number? It says if x is between 0 and 3, right? So 0, 1, 2, and 3. What's my y values?
4. 4.5.
Did everybody get these?
Yes.
Why did you not? Or do you understand why now, or? Okay, are you sure?
Yeah.
Okay. So when we're graphing our first graph, right? We're starting at 0, 1, 2, 3, 4. Is that an open or closed dot? Are we including open dot? Yes. There's my open dot.
What?
It is, because I just put a regular dot in and I realized it was open, so I made a really big circle around it. I was just dotting my points to start with. Okay, so now at -1, what's my value?
4.
-1 is 6, right?
Oh, yeah.
Okay, -2 is at 8, and then -3 is at 10.
Are the middle of those things closed? Are
The only ones that you're gonna do open close is your ending point.
so is that just that big one?
This one right here is the only open one,
10?
because everything else is part of the equation, right? And this one does not have a stopping point because it just says x is less than 0, so it continues on forever in the less than direction. Does that make sense? So we don't put like a stopping point on it, like we've done some of the past. However, our second one does have a stopping point. It's saying only from 0 to 3, right?
Yeah.
So at 0 we're at 4, and it's not included again, right? At 1 we're at 4.5. At 2 we're at 5. And at 3 we're at 5.5. Are we including the 3, 5.5?
No.
No, because it doesn't have a what?
Equals up.
Equal sign. So this is your final graph, right?
It's like an L.
It's, well, my last class we said it's like a backwards check mark. You see that?
It's
Or
like-
an L. I guess you can make it
An
a-
L for Lauren.
For Laura.
L for one.
L
Okay.
for loser.
Yeah,
Back-
nice guys,
back
be
to
nice,
the
be
graph.
nice. Okay, so everybody good on this? So once again, if I asked you, listen, if I said, find f at -1, what are you going to tell me? F at -1. 6, right? Does everybody see that?
Yeah.
Pay attention to the board real quick. If I go at -1, my graph is at 6. Okay? So if I tell you, what if I say f is at 3?
It's at 5.5.
But is that included in our graph?
No.
No.
So is that really part of our graph?
No.
No.
So what is f at 3?
Nothing.
Nothing. It's either no solution. I would say probably no solution. Okay?
Probably.
Yeah, because I mean, if it's not part of your graph, it's not a solution to your graph. Does that make sense? Okay, everybody good?
Yep.
All right, so your assignment for the rest of the class period, you have about 30 minutes, is
I think you need to go like really quiet.
No.
You need to go to the hospital.
It's a headband.
what? It's going to be 5 problems, and they include the same